will definitely, because no, this is just out of my own academic to industry initiatives. I do this recording and I used to keep it on my YouTube. No, we have a channel in Leming
Okay.
Solutions, so I should transfer this video to that specific reciprocatory so that viewers can view this and they can get benefited in whichever way they want to take things forward. So maybe people like you from out of this industry or out of this domain or vertical can also get benefited from this particular session that I hosted
Yeah.
from my own personal interest.
Thank you. Thank you so
No
much.
issues, Karthik. So I will just try to share my screen and I will let others to join whenever they feel like join.
Yeah.
I don't know if we have any option for the people to join by themselves rather than me giving them the permission. Sometimes I used to do some settings. So just give me a second, Karthika. We'll look at
Yeah.
if I can do something to the settings. Oops. In Zoom meeting, I don't have any privilege to do this. Anyways, no issues. Okay. So I will share my screen and just let me know if you're able to see my screen.
Yes, I can see.
Okay, thank you. So, good morning, all, and today, welcome to the today's session to talk on the CAD to the concept. And Basically, I will start with my brief background that I'm Satish, and I have been in this industry for last 25 years. I worked for exclusively for the interiors and for exteriors body engineering with the various tier one organizations such as IAC, Plastic Omnium, Tata Auto Components, and I was handling for both interiors and exteriors for customers like Tata Motors, Ashok Leyland, GM, few, and for all for the different scope of business entities for business like full service support or for the build to print. And I am currently pursuing my PhD from Amrita, and also I am more of an and startup entrepreneur. And also, I'm an adjunct faculty for BITS Pilani for WILP for the systems engineering program for MTech automotive engineering teams. So the whole objective of this a CAD or the concept to the CAD is to, as we all know, that the whole objective is for an organization to empower them with growth. Okay. So that is the whole objective of any vertical who is going to or the whole and sole purpose of any organization to invest that time and money is to only ensure that they are able to grow successfully in terms of the market share and also in terms of the money or the return on the investment. Correct, right, Karthika?
Yes, Satish. Yeah.
Yes. So I think
If I
most
have
of the
doubts, can I ask in between?
yeah, sure. No issues, sir. Okay. And I think most of the time, what we do is that we try to technically get inside the work as the moment we get any orders or any business proposals or any RFQ or statement of work from the customers. But we very seldom look from the end user requirement. That is what is we normally we don't try to spend more time on how exactly the end users are going to behave or how they're going to make use of the product what we are actually designing, because normally what we do is that the customers they send us an RFQ with all the technical requirements, the this application requirements or the DVP or the load requirements, and we start developing any benchmarking or concepts, and then eventually we start progressing the design accordingly so to meet the performance requirements as specified on the SOR or on statement of work window. But we don't actually get an opportunity to witness what is the end user's requirements. That is what we lack, and that's what being preached on this design thinking approach. When you look at this empathy, that is the first point from where we start when we look from the design thinking approach. So for that, these are the two different verticals which we'll have to primarily focus on. One is on the voice of the customer, and second one is the design. So I think we can go through this particular progressions, but this particular chart which shows is that we need to look at more of an emotional value. Whereas, well, yeah, I think for sure, like we all look at the from this application point of view, we look from the product value point of view, but we never look at the end consumers, whether are they feel happy or whether they feel comfortable to use this product on their day-to-day life. Do you agree with this point, Karthik, to a large extent?
Yes, Satish. Yeah, we have to
Yes.
at the end. I mean, from the very beginning, you have to see whether the
Mm,
customer's voice is.
agreed. Agreed. So we always think of how we try to reduce the cost, how we try to reduce the hours, how we try to squeeze the maximum from the resources so that ultimately we are able to scale up the business and we are able to scale up our market share, how we are going to promote ourselves in the media. So that's what we all more focus on most of the organizations, but very less we spend on these two activities where I think going forward people really need all the engineers or the design engineers, whom I specifically tell the technical engineers who are giving or who is the backbone of any organization or for any product. So he should look from a very holistic picture. So this is a basic principles which are being involved for the design thinking approach, which starts from the user centric. So you need to really understand what is the pain of the customer or what is actual, the issue which he is facing. And then, okay, for example, if I take a small example, if you see there's an MRI machine or a CT scanning machine where we go through or we lay horizontally on a bed and that moves to a tunnel where it starts imaging, scanning and imaging our brains and the pictures, correct? Correct.
Yeah,
So, but when it comes to pediatric portion for the young patients or for children, they always have a fear factor to get inside that room because you feel that as if you're getting into some ghost house, and they somehow wants to come out very immediately and they don't want to, go through the complete examination. So what this G healthcare and all they did is they came up with a very like a like artistic. They had a paintings on top of these missions with a lot of children artwork and garden types and all, so that these people or the young children when they come inside, they feel they are coming to some place called. They don't feel that they are inside some hospital or inside a lab. So they really enjoy the experience. So technically speaking, from the MRI mission point of view, technically they are able to do their work. And at the same time, they are even able to understand the pain of the customer and they are able to satisfy their needs also. So that is how we are trying to take one of the examples of this design thinking approach. You are getting it right, Karthik?
yes, Satish.
So this is something what you cannot do it by yourself. You need to have collaborate within your team. It could be from manufacturing, production, quality, PQ, or even from the external agencies, your customers, vendors, suppliers. So you will have to come collaboratively and think about how we can try to come with a unique or a novel product by which you are able to meet the end consumers' requirement. And it is more of a iterative process. It is not that once you do it and that is the like end of the product cycle. So you need to have a mindset or a positive attitude that there could be a better solution by you do one or two or three extra loop of your iterations. You should have that iterative process as one of your one of your skill sets to the journey of this design thinking. And it should be also on a very holistic picture. You should think from a systems point of view, a deep dive into the technicality, or the functionality or the application point of view. You just don't need to look from the top of it, but you also need to understand it deep. Deep means in terms of what could be the probable failures or how to overcome it or what would be the right process or the methods, whether are we using the right design guidelines, the best practices, the best principles. There are many things in terms of documentations, but very seldom we go through it systematically on our day-to-day life in any corporate. That or not, Karthika?
Yes,
Mm.
we have the documents, but we don't generally go through those one by one.
Correct. Yes, we are totally busy with our day-to-day KRA and KPIs and with our targets being given by our boss. No, it is not something
Yeah.
that I'm not trying to deny on that fact. But again, we are all being very much concerned about rolling out a product rather than
Yes.
customer requirements. That's what. So then what happens is that then they come at a very later stage of the time that so and so changes has to be done. Once again, we are going to incur a lot of money and effort, and gradually there will be an ECN or the engineering
Change, engineering change.
change. Yeah, it will be very huge by the time it goes to the development phase. Again, you have to come back to the concept stage, redo the design FEA study,
Everything from
like
scratch again.
prototyping. Then again, who is going to spend money on that? Then there'll be one sort of a non-recurring cost. No, neither we can bill from the customer, so we have to burn from our own pocket. So again, your KPI is gone, your promotion is gone. So it is all
Exactly.
it's a cycling process. Again, yeah, yes, that somehow some few organizations do respect to go through all this. Maybe some product-based companies like Bosch or Denso, ZF, and all. Probably not much into the service companies, but I think those
Yes,
type
sir.
of product companies they would more respect to the customer requirements, and we should be more optimistic. We should have some space to bring in new ideas, fresh perspectives, so that we can try to innovate good products. Design of experiments, because if you are to bring in any no one, then for sure, like we have to go through and do preparation about how to come across a new solution. So for which we have to do good number of DOEs. And the final one is a tangible quotient by by the different means we are trying to bring out a innovative product. So in the nutshell, it is all about some of the like prerequisites for how you have to bring on to the a novel product which should be satisfying the end user. Okay. Yeah.
Yeah.
Yeah, I think this is one slide which I've just very recently tested on this PPT. So this basically talks about the generic process flow, about how the design and development takes place right from the RFQ, RFI, where we try to understand the technical requirements from the customer. Then we start developing the first timeline, the resource planning, who will be working on the project. And based on the RFI or for the SOR, then we try to give back in the form of a technical analysis back to the customer with our assumption and perceptions on whatever we got the information through the document from the customer. And then we try to have a technical sign off. Then finally we do the DFA, DFM, and value engineering as part of our cost cutting proposals through benchmarking or from the previous project lesson learned. And then we sign off for the program go ahead. So I think this is the N minus one categories when we look at the engineering or a program timeline. This is how we start the project. And then we go through a very methodological process about evolving a product design. We start from the engineering design and development activity planner on a weekly planner. Then we have the resources and the budget in terms of the hours, how we are going to spend. And we have the DVP and the DFME, which are part of your design evolution, which goes in the iteration in like revision one, revision two, before you actually release a design for manufacturing. Then we start with the conceptual sketches based on the initial inputs what we get from the customer. Then sometimes we do proto 3D if it's a novel or a new product innovative. So we don't have any previous lesson plans. So for which we'll have to do some SLA, SLS or a 3D printing to really understand whether the concept works or not before we spend time on the design evolution in terms of mass sectioning or close volume or development because there is a very time consuming activity, the 3D activity. So before we burn the hours, we should make sure whatever the concepts that we have evolved through the freehand sketches or through a rendering through the 3D printing to make sure that we are able to meet like whatever the technical specifications that we got from the customer. And once we do the first loop of the FEA, then we try to understand the problems that we are not able to meet the or not able to respect the DBs. So we do the root cause analysis using 5A analysis or the 80 analysis, and then we get to do the risk assessment in terms of the program or also in terms of the FMEA revisions. And then we do the detailed designing, then the 2D drawing with the GD&T, then the toolmaker comes on board, and then we release a design for manufacturing. So this is how the generic body engineering design evolution happens until the design has been released for manufacturing. But I think for powertrain, it is a bit different, right?
Same, I think same, Satish. Same
It's
process
only
is
the same
followed there
problem.
also.
Okay.
Yeah.
And then once the design is being evolved or the product is being evolved, we are going to launch the tooling, we are going to do the tooling development follow-up, the trials follow-up, and also we do the DVP holding picture development. We also try to develop the checking gauges, discussing with the supplier, sharing with them the right data, the drawings, data schemes. And then finally, we do the vehicle fitment, like the product fitment, vehicle fitment. Then the same root cause analysis, change management for the cost and hours from the customer. And once we launch with the different phases of your vehicle build, then finally it goes to the start of the production. And then we used to capture the lesson learned or REX or returns on experience on whatever we have gone through the different milestones of the program. We record it on an Excel sheet so that it can be transferred to the next project. It will be easy to filter and go through phase by phase on each phase what all problems that we have occurred and what is the mitigation plan that we have taken. So it makes the development cycle for the next project to be reduced, and also the cost is also getting hugely reduced because we don't need to repeat the mistakes. And then we take care of the SOP plus 3 months of the project. Or once it gets launched, there will be a lot of field issues which come from the customers. So this is what we spend a lot of time here. So when the end consumer is going to use it, then he will have his own perceptions, and again we will route it to the VCR, and we try to rewrite the stories. And I think this rest will remain the same, like APQP and TS 16949, and the finally these trains and things like will be a part of your learning and development phase for your staff. So this is the complete story of how you take up the project. So I think this has been a very like in a phase wise. I have illustrated about what happens at each phase of the things. So I think this is a very initial phase what we have also discussed on our earlier slide. So here it talks a bit more detailed about the design, right from the conceptual. We try to develop the classes surface is something what we receive once we are a build-to-print supplier or an FSS supplier. We and where we are the responsible or the tier one supplier is responsible for the design. Then normally he receives the classes surface from the styling studio. From there, he has to split the surface based on the initial BOM, what he got from the SOR. And then we used to develop the mosaic sectioning and the packaging study. And then we do the preliminary 3D designing, then the design review 1 and 2, DFME, design convergence. So I think it's very common, right? This is what we also do it
Yes. Yes,
on the
Satish.
first
We
phase
do the
also.
same.
So again, then we go to the tool makers feedback, checking gauges feedback, geometry feedback, gap enclosures, whether we are able to meet the PQ perspectives and a lot of things stuffs. And then we go for the manufacturing. But again, I think if you look at from an organization point of view, only the seniors who has a prior experience, they'll be able to actually converge the problems during the development cycle. But unfortunately, most of the seniors, they would be on the top level, on the leadership level. They would not be interested to come down to the operational level. So on the operation level, once again, the same engineers and the same senior engineers, they will be
Yes.
struggling. So
Uh,
that is the iterative process, what is being happening, and it is getting and keep evolving in all places, not only in OEMs, in tier one, tier twos, design services. It is all what is being happening everywhere in every project in every program. And
Yeah.
yeah, that is what just wanted to give you a brief understanding, because if you have any specific doubts, then we can take it up, Karthik, in terms of this design thinking approach, or in terms of body engineering, or in trims commodities.
Uh, so I am specifically more interested towards how a product is conceived in Sketch, and then how it is taken up into a CAD. That particular stage I am more involved.
Okay,
I want
okay.
to, so
Mm.
for example, they have some problem statement. So how
Mm.
they take it up in a Sketch and how they proceed
Uh,
into CAD, how they do
okay,
it.
okay, okay. Yes, I got your point. So if I just look at from this typical program timeline, so here is where we are going to start the project, or from the SOR, or whatever the stage where we have been normally normalized, or we have been awarded to start on a project. So we have been awarded the project, and we also have the vendor on board of the tier one, and we start the engineering design and the development from here. Correct? Mhm.
Yeah.
So prior to that, we have like n minus one stages where we have this RFQ stage, and prior to that, we have an request for study stage, and prior to that, we have got a request for information stage. So this comes minus 3 months. Sorry, this is completely minus 6 months, minus 3 months, minus 2 months. So I think this is with the thumb rule what is being taken. So if you look up from this particular trims, or from the exterior point of view, where we have this is a front bumper. We have this grills on the fog lamp, colors on both sides. So the styling studio, look, what is their role is that they have launched one specific program for 2024, one base model, and eventually once this styling surface is being released to the engineering team to develop the 3D designing, then their work is not much involved, because then they will only come to the picture during the industrialization phase for the signing off with respect to the color, material, and the finish. So some of the engineers, they might come to the plant, and they will give a go ahead for the mass production. Cut or not?
Yes. Yes.
So in between this phase where the toolings are getting developed, or because you got some 3 to 4 months for the design release, and then you got another 3 to 4 months for the manufacturing of your T0 sample. So in this time period, this styling studios guys, they will work on the model year 2025 for the facelift project. Okay. So what happens is that this particular 2024 model, they will try to exhibit it in some showrooms or in some shopping malls. Okay, I'm just trying to like exaggerate the topic. So even they'll show this to cross-functional team on one organization. That could be within the engineering team or like operational team and all, and they will make some clay model of this 2024 for a book model, and from that they will try to give some feedback, or this will be showcased within the organization to the entire plant, where all the members can come and participate, and they can give their voice of customer, VOC mode. So on one Excel sheet, even their names and department won't be mentioned, but they can give their voice, like what all things they feel that can enhance the consumer preferences in terms of feature addition, or in terms of the aesthetics or ergonomics point of view and all. They will try to give their comment. So whatever the market plus the internal agencies or the external agencies feedbacks are being given, they would be studied by the project team, and also combined with the styling studio. And those feedbacks would be incorporated in the model year 25 for the facelift styling surface. Clear? Mm.
Yeah. Yeah. So it
So
basically starts from the industrial design thing.
correct, correct. So they just come up with a freehand sketch, or with some freehand like ISO view and all, that need not meet the regulations, that not need not meet the engineering feasibility requirements. So basically, they will try to give some a very rough initial idealization sketches, and those idealization sketches would be transferred to the engineering team. And the engineering team of an OEM or a tier one together, they will do the feasibility study in terms of regulation, ergonomics, packaging, from the vehicle architecture point of view, and then they will give the study back to the styling team that whatever the idealization surfaces, whatever you are given, is not able to meet entirely to this homologation or to the standards or regulations. So they will try to do some tuning, and then they will once again resubmit it back to the engineering team. So this
Okay.
iteration study will go for 2 or 3 times, and finally this styling team will give the final released engineering surface, complete vehicle engineering surface. And from this engineering surface of the vehicle, these specific aggregates or these or the specific like the team of an organization for exteriors or for interiors, they will split the surface and they will give this particular or the trims or this exterior um, trims the team. They will handling this front bumper and the rear bumper or the spoilers, like whatever it comes. They will take this surface and then they will share it
Okay.
with the tier one, and then they will start the design activities. So that is what they will do from here.
Okay.
Clear, right? So
Clear.
to just answer your question, it is the industrial team or the CMF team, or not the CMF
Styling
team,
team.
yeah, styling team, because CMF team is a separate entity within the studio team. So they are more concerned about the material finish or about the texture to be given or the finish. So they will start interacting with the paint suppliers or with some, like engraving suppliers or texturing suppliers, and then they will try to define what should be the texture, what should be the texture depth, and accordingly what will be the draft for for the parts that face feasibility for manufacturing feasibility and all. They are CM. And this industrial designers is they will take from a complete picture of a full vehicle that will be for a trucks or that will be for passenger cars. And then they will see from the market perspective of how the futuristic vehicles, what are the features that has to be added. Those will be done by the industrial team. And the CMF team is more concerned about all this color, metal, and the finish, which has to be included inside the portfolio of the industrial team's decision of the surface. Clear?
Okay. Clear.
So that is how we do the things doing this RFI or doing this RFS study. That is a very early stage. And by the time it comes to this RFQ, the surface should have been matured to at least 80 percentage. And then the engineering team would make it from like 80 to 100 percentage. And then they will release this surface to the nominated tier one supplier. And then they
Hmm.
will take it up either through the build to print or through the FSS. Right? Progression be design evolution. Done.
Yeah.
So we have anything else, Karthik, to be answered?
Um, so overall flow I could able to visualize,
Okay.
and yeah. Um,
Okay. Or if
yeah.
you still have any doubt, you can contact me through my WhatsApp number. Okay, I'll be happy to help you out because I only got another like 9 minutes to go for this meeting. So if you have any specific questions, then I'll be happy to hear the answer of your WhatsApp.
So um, so basically this kind of with respect to component part design level.
Mhm.
So how we have to do this draft analysis and those kind of things. Uh, how we have
Draft
to carry on.
analysis, component level draft analysis would be a part of your engineering release or the engineering surface release, whatever you have released it. Because in the initial and very initial surface, what they have developed, that may not have included any of the engineering inputs. But when they gradually start updating the surface, they will try to involve the tier one or the OEMs. They directly deal with the the filmmakers, and then they try to get their feedback. And based on the depth of the component and based on the grain texture depth, the draft is being considered. It could be from 0.5 degrees to 7 degrees based on the depth and based on the texture depth. Clear?
Clear. Yeah.
So if a component is say 5 mm of this height with a very mild texture, with 1 degree or 1.5 degrees can do. But the moment your component height is getting increased, then you will have to gradually increase the draft height so that this part can be released in the injection mold without any surface defects or scratches.
Okay.
So the draft is being given basically not only for removing the part from the cavity, but also
Mm-hmm.
to avoid seeing the scratch marks or scoring marks.
Okay. Okay. Okay.
Yeah.
Yeah.
Anything else?
Yeah. Um,
Suppose if you have
uh,
any specific, you can just reach me out on your number. It is 755 961
double
04
$755 961.
04. So you feel free to ask me anything on the podcast side. I'm happy to help you.
Sure, Satish. Yeah.
Okay. So I think that's it from my side. Thank you, Karthik, for having participated and having taken time from your basic study.
Thank you, Satish.
Thank you. Then. Have a nice day.
Satish, will you share that PPT to us?
Yeah, sure, sure. That I can go with. No issues.
Yeah.